Hey everyone, welcome back to the channel. Today we are diving into another two-pointer problem, container with most water. This problem 13 in our list, and if you like the threesome question, you will enjoy how clever and visual this is. So let's read the statement. You are given an integer array heights where heights I represents the height of the ith bar. You may choose any two bars to form a container. Return the maximum amount of water a container can store. And we have examples here, a couple of examples. The input format is array and the output is the max area itself. So imagine you have got a set of lines drawn on a graph. Each line represents the height at that position, kind of like the bars in a histogram. And the challenge is we want to find two lines that together can form a container holding the most water possible. The container is basically the area between those two lines. So suppose we have these two lines, the green lines, and this creates a container. Well, the water you can actually keep in your container depends on the shorter of the two lines, not the taller one. Why? Because water will always spill over from the shorter side. So suppose we have these two bars. So we will have to consider this one instead of this, because if we choose this, water will spill over. And of course, the wider apart the lines, the more potential area they cover. So we need to think about both the height and the width. So let's break it down in a simple way, just like we did in threesome. So I'll take this example. So first of all, we start by placing two pointers, one at the beginning and another one at the end. So this will be our left pointer and this will be our right pointer. So one points to 1 and another points to 6. So imagine these two lines as the walls of your container. So suppose this and this. And the distance between them is just their index difference. And their index difference is basically the width. So 6 is at position 7 and this is at 0. And height will be determined based on the shorter one. So the minimum of the two, 1 and 6. And this is our height. And then we calculate the area, which is just the height of the shorter line times the distance between them. So area equals 1 times 7, which equals 7. That's our starting area. And here is the clever part. To try and find a container that holds even more water, we want to move the pointer that's on the shorter wall inward. Why? Because if we move the taller wall, we are guaranteed not to find anything bigger than that. So suppose we are here. So right now we are here and 1 is smaller than 6. So we move our left pointer. So we move it one step forward. So now our height is changed. So here our height will be minimum of 2. Again, 7 and 6. So now we have 6 as height and width will be the index difference, 7 minus 1, which is 6. Now our new area is 6 times 6, 36. Sorry, it's 36. So we repeat this process every time we move a pointer. We recalculate the area and we keep track of the maximum area we have seen so far. And we keep shrinking the distance between the two pointers until they meet in the middle. So now we understand this problem. Let's write the code. I will comment these out. And as usual, we are using Python here. So first of all, we need our 2 pointers, left and right. I'll basically store the height of the size of the array in a variable n, because we are going to use it multiple times. So left will start at index 0 and right will start at last index. And how we get that? N minus 1, because our array starts at index 0. Now we need another variable called max area, which we are gonna return at the end. We simply initialize it with a zero value. Now we start our loop while left is less than right. What we do here is we calculate the area. And area will be the height times width. And height, how we get height? We basically take the minimum of 2. Heights left, comma, heights right. And then we multiply it with the width. And how do we get the width? We simply subtract the index values. So right minus left is gonna give us the width. And then we check if this area, if the current area is greater or less than our max area. So if max area is less than our current area, we simply replace our max area with the area. Let me remove this to make some more space. And now, to check all the combinations, we move our pointers. How we do that? We check if heights left is less than heights right. Simply what we did in example 1. 1 is less than 6, so we move our left pointer. So if heights left is less than the value of heights right, we move our left pointer one step inward. Otherwise, we move right. And finally, we return our max area. And that's it. The biggest area you get during this process is our answer. Let's run this code just to see how test cases perform. You can see all the test cases are passed. And that's it. This method is only taking a single pass through the array, and the time complexity becomes big O of n here. The time complexity is big O of n. This is efficient since each pointer only moves inward. No need to nested loops and brute force combinations. It's a classic use of 2-pointer technique, and just like with 3-sum, once you see the pattern, it feels so satisfying. If you found this breakdown helpful, give it a thumbs up, subscribe, and stay tuned for more problems walkthrough. Next up will be another 2-pointer problem. Thank you so much for watching, and happy coding!